Welcome to this explainer. Today we're diving straight into one of the biggest logistical and, let's be honest, economic puzzles in the offshore energy world. Think about it. You've just spent millions exploring a patch of ocean, you found a great reservoir, and now you want to get that oil or gas flowing as fast as humanly possible. But building the colossal fixed platform required to extract it safely? That takes years. So how do you bridge that gap? Well, let's look at the brilliant piece of engineering that lets offshore developers basically hit pause on a multi-million-dollar well deep underwater. Picture this. You've got a major offshore field development on your hands. You already know that fabricating and installing your permanent production platform is a massive undertaking that's going to take a ton of time. So here's the multi-million-dollar question. Why wait for that permanent platform to actually show up before you start drilling your wells? Because if you wait, you're literally just pushing your revenue further down the road. And in our industry, waiting is insanely expensive.
Right. It all comes down to that classic offshore mantra. First oil, sooner equals sooner revenue. Time is quite literally money here. If we can just get the drill bits turning while that giant steel platform is still sitting in a fabrication yard somewhere, the project's economics totally transform. To pull this off, the industry relies heavily on a strategy called pre-drilling. We bring in a temporary mobile vessel, like a jackup rig, to drill the development wells right out of the gate. Boom! First oil hits faster, and the cash flow starts way earlier.
Section 1. The pre-drilling problem.
That aggressive economic strategy introduces a pretty huge physical dilemma, though. We are talking about drilling a well thousands of feet deep. Normally, your wellhead sits nice and secure up on the deck of your permanent platform. But if you're pre-drilling with a temporary jackup, where exactly do you put the top of the well when your permanent structure doesn't even exist yet? Enter the hero of our explainer, the Mudline Suspension System, or MLSS. It's basically a genius way to put a well on standby. Instead of extending the casing all the way up to a surface platform that isn't there, the MLSS lets you hang off and completely seal those massive steel casing strings right at the mudline, which is just the industry term for the seabed. It safely puts this massive project to sleep, perfectly preserved underwater, until you're ready to wake it up.
To really grasp the scale here, just picture the seabed floor. That's exactly where the MLSS sits. Below it, you've got your conductor pipe, and nested inside that, your intermediate casings plunging thousands of feet into the reservoir. Now, a single string of that casing can weigh tens of thousands of pounds, and the MLSS is sitting right there at the mudline, taking on absolutely all of that weight. It acts as this incredibly robust anchor point, holding everything securely in place while the rest of the project catches up.
Section 2. The 6-step sequence.
Of course, you can't just drop a pipe and say see you later. Setting up an MLSS is like a massive, perfectly choreographed industrial relay race. Here is exactly how the 6-step sequence plays out. Step 1, the temporary jackup rig gets into position and actually drills the wells. Step 2, each well is completed right up to that mudline suspension point, so the casing strings are hung and tightly sealed at the seabed housing. Step 3, we install a protective mudline cap over the whole thing. Step 4, the jackup rig packs up and moves off location. Step 5, fast forward a bit, and the shiny new fixed platform is finally installed directly over those pre-drilled wells. And Step 6, the platform's equipment connects to, or picks up, those suspended wells so they can be fully completed for production. The baton is successfully passed.
Section 3. Hardware under pressure. Now just think about the sheer physical reality of what we're doing here. We are leaving absolute tons of steel in a highly pressurized, completely corrosive underwater environment, and we fully expect it to work flawlessly when we come back. So MLSS hangars has to meet some insane requirements. First off, they have to maintain a perfect seal for months, sometimes even years, while that permanent platform is getting built. A leak down there is a total disaster. Second, they have to be completely re-enterable. When the platform rig arrives, it needs to run tools straight back into that well without a hitch. And third, the hardware needs to handle the mechanical transition from a jackup drilling setup to a fixed platform completion setup. We're talking extreme precision engineering under literal tons of ocean pressure.
So when that permanent platform finally does show up to wake the well back up, it's not like you just flip a switch. The rig has to run what's called a wash pipe, or a re-entry assembly, all the way down to the seabed. This wash pipe's first job is to latch onto and recover that protective mudline cap we installed earlier. Once that's out of the way, it reestablishes fluid circulation to make sure the well is safe and stable. Only after all that is done can the crew actually finish the completion, which means running the production tubing, getting the subsurface safety valves in, and setting the downhole packer.
Section 4.
re-entry, and risks.
As you can imagine, this entire operation is a serious balancing act. On the plus side, the economic benefits are just staggering. That's exactly why the MLSS is used so heavily in giant North Sea and Gulf of Mexico developments. Pre-drilling massively accelerates first oil. But there's a very real catch, and that catch is time. You simply cannot leave a well suspended forever. If it sits down there too long, the ocean definitely takes its toll. The casing steel starts to corrode, and those absolutely critical seals begin to degrade. And if a seal fails at the mudline, you've pretty much lost the integrity of the entire well.
Which leads us to a really fascinating dilemma. How long is too long to leave a well sleeping at the bottom of the sea? It's a massive risk calculation that petroleum engineers have to make every single time they plan a pre-drill. They're literally racing the clock, weighing billions in early revenue against the crushing, corrosive reality of the deep ocean. The Mudline suspension system is a brilliant, game-changing innovation for sure, but it's a great reminder that in the offshore world, every single solution comes with its own ticking clock. Thanks for hanging out for this explainer. I hope it gave you a whole new appreciation for what goes on beneath the waves.